Hello Physics 20. I'm going to make a video example today involving pulling a mass up a hill. What's different about this one is we'll find the maximum mass that can be towed with a given applied force. So here we have a snowmobile, it's pulling a trailer up a hill. We've got the incline here. Coefficient of friction is 0.25, and we'll find the maximum mass the snowmobile can pull up the hill with this applied force. Okay, so let me illustrate the familiar setup here. We have a hill. It is 15 degrees. This box here will represent the sled that's full of firewood, or the trailer I should say. All right, looks fine. Now the forces, we've got gravitational force straight down, which of course can be broken up into components that are perpendicular to the hill, like this, and parallel to the hill like this. Okay, so we've done this dozens of times. Those are the components of the gravitational force, Fg. Okay, I'll just get the normal force out of the way. All right, in this case, the snowmobile is being pulled up the hill by that applied force. So the applied force is going to go up the ramp like this. All right, I'll label that as applied force, but we know that it's 2,000 newtons. Okay. And if this thing's going up the hill, that means that friction must be down the hill. Here's all of our forces at play. All right, so we'll have to make a logical argument at some point, make an equation we have to solve based on this diagram. And maybe it's not clear how to get started, but we've seen before it's never a bad idea to write down some formulas that we're going to be looking for. So the parallel force, mg sine, perpendicular force, mg cosine, friction, mu, in this case times the normal force, which will be mu times mg cosine. That might look a little bit new to you. All right, but the normal force is equal to the perpendicular force. So our friction here is going to be mu times the normal force, which is mg cosine. Okay, so I've just placed this entire thing into the normal force, mu times this. Okay, now what's challenging about this question is we don't actually know the mass, so we can't calculate these guys. And you're going to see there's just a bit of algebra to do in order to solve the problem. But once we get there, I think you'll see it's not too bad. Let me get it set up over here. So the applied force is up the ramp, and this parallel force and friction are down the ramp. If you imagine you keep adding mass to the trailer, it'll actually increase the parallel force down as well as friction, because it'll increase the perpendicular force. So if you imagine towing a sled up, you could keep throwing wood onto the sled until it was no longer accelerating, until you reach some maximum where the sled will go up very slowly at a constant speed. That'll represent when the net force equals 0. All right, which will mean that the 2,000 newtons up the ramp is being totally killed by the two forces down the ramp. Often I just skip to an equation that makes sense in my brain like this, that in order for this thing to go up, the maximum mass will occur when the applied force up the ramp is equal to the two forces down the ramp. Okay, so applied force up. Okay, if the forces down the ramp overcome the applied force, well, the snowmobile is going to struggle and the sled will start to go down. Okay, so we certainly can't have more force than this equation represents, and it also represents a net force of 0. Okay, so let's see what that looks like on a fresh piece of paper. I'm going to lead with that. Keep everything visible. So I'm going to write that my applied force is equal to parallel plus friction. My parallel force is up here, mg sine. Friction's here, mu times mg cosine. And I know my applied force is 2,000 newtons. Okay, check it out. This isn't the nicest thing to look at, I realize, in grade 11, but we know g, we know theta, so we know everything except for mass. Like, we know mu. Okay, so let me just sub in all the values that we have. We're looking for mass, but we know g. The angle is 15 degrees. We know mu. Looking for mass. Angle 15 degrees. Okay, I'm just going to clean this up. I'm going to do 9.81 times sine 15. And I get 2.54. Now, this represents things multiplied together. The order doesn't matter, so just leave this m alone. I'll deal with it at the end. So I'm doing 0.25 times 9.81 times cosine of 15, and I get 2.37. That's going to be times m. I'll write it in the same format as the first one. So it's m times a number plus m times some other number equals 2,000. This is what we have to solve. And I'm going to write it in a way that it should make it look more familiar, with a variable after the coefficient. Okay, so maybe this looks weird to you, but if this was in math class, it would look totally normal, especially if these m's were x's, right? You have some number times a letter plus some number times another letter. They're the same letter, I should say. You just add the coefficients. Okay. If you were asked this in Math 9, you would know exactly what to do, and the rules don't change. So I'm just going to add these two coefficients together. I got 4.91, and the m is still there. Right, maybe to belabor this a little bit, but it may help. This is no different than saying 5x plus 3x, right? Every single person would know that equals 8x. Any single person in physics 20. So this is the same. You're just adding coefficients. The variable sticks around. Okay, last step here, we just have to divide. All right, so I'm curious how much firewood we can pull up the hill. Divide there, I get 407.5, and that'll be in kilograms. All right, I hope this helps, and good luck.